Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.102. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. Ohm's law will also be utilized while solving this problem. According to this law, voltage across any resistance R is the product of current through this resistance and the value of resistance itself. Now move towards the problem. Exercise problem number 2.102. Find the value of resistance R in given below figure, such that 3 ampere current source is absorbing power of 12 watt. This is the circuit diagram of given problem. Inside this network, we have to find the value of this resistance labeled as R. While one information is given, power absorbed by this 3 ampere source is 12 watt. So without wasting time, let's proceed towards the solution. First of all, we will try to find out voltage across this constant current source because power of this current source and the value of current is provided. We will use power conventional formula, that is the product of voltage and current. If we know any two quantities, we can calculate third quantity as well. In this case, power of this constant current source and the value of current is given, so we can calculate voltage across this constant current source. So the value of voltage across this constant current source will be 12 watt divided by 3 ampere. Voltage will be equal to 4 volt and the polarity of voltage will be positive terminal here and negative terminal here. Because we know that in order to absorb power through an element, the current should enter from positive terminal and leave from negative terminal. Modify the network by indicating voltage across this constant current source with their polarity. Now this same voltage with the same polarity will be appearing across this 2 ohm resistance because of parallel connection. We can calculate current through this resistance because voltage across it is known. So the value of current will be 4 volt divided by 2 ohm. It will become 2 ampere. 2 ampere current will be flowing through this resistance and the direction of current will be downward because in order to make this terminal positive, current should enter from this terminal and leave from this terminal. Modify the network by indicating voltage across this resistance and current through this resistance. Now we can apply Kirchoff's current law on this node to calculate current through this branch. Write KCL equation for this particular node. We are assuming current I is flowing through this branch and it is entering towards this node. While two currents are leaving from this node, one is 3 ampere and other one is 2 ampere. Leaving currents are taken with negative sign and entering current is taken with positive sign. Now add minus 2 ampere and minus 3 ampere together, it will become minus 5 ampere. And place this minus 5 ampere on the other hand side of equal to calculate the value of I, that will be 5 ampere. So 5 ampere current will be flowing through this branch in upward direction, entering towards this node. After knowing the value of current through this branch, we can calculate voltage across this 1 ohm resistance, that will be the product of current through it and the value of resistance. Current through this resistance is 5 ampere and the value of resistance is 1 ohm. So voltage across this 1 ohm resistance will be 5 volt and the polarity notation across this 1 ohm resistance will be positive terminal here and negative terminal here because current entering terminal is taken with positive sign. Modify the network by indicating voltage across this 1 ohm resistance. Now we will apply Kirchoff's voltage law inside this closed loop to calculate voltage across this R ohm resistance. For that purpose, we are assuming the direction of current in counterclockwise and according to this assumed direction of current, polarity notation across this resistance R is marked. Write KVL equation for this closed loop. Start from here. Current entering terminal is positive, so 4 volt will be taken with positive sign. Next, current entering terminal is positive, so voltage across resistance R will be taken with positive sign. Next, current entering terminal is negative, so 12 volt will be taken with negative sign. Next, current entering terminal is positive, so 5 volt will be taken with positive sign. Now add 5 volt and 4 volt together, it will become 9 volt, and subtract 9 volt from minus 12 volt. The answer will be minus 3 volt because larger value have minus sign along with it. Place minus 3 volt on the other hand side of equal to calculate voltage across this resistance R, that will be equal to 3 volt. We know the value of current through this branch, that is 5 ampere, and we know the value of voltage across this resistance R, that is 3 volt. So we can use Ohm's law to calculate value of resistance, that will be equal to 3 volt divided by 5 ampere. So the value of resistance will be 0.6 ohm. So this was exercise problem number 2.102. Thank you. See you again in next video.